Hi, welcome to this tutorial, the fifth in my series on permutations and combinations. And what we're going to look at in this tutorial is still sticking with restrictions, but when we've got items in a line and certain items have to be at the ends of the line. Now in the first example, which you might like to try, just pause the video if you want to do any of these actually, and just come back when ready. But in this first example, we've got how many ways can 2 men and 3 women sit in a line if the men must sit on the ends? Well, what I'd want to do is write down our 2 men as M1 and M2 and 3 women as woman 1, woman 2 and woman 3, so I can distinguish the 5 items. And then I would most probably draw out something like this as the seats. And I'm looking for the number of ways that they can sit in these seats, the number of arrangements. So how many ways can the end seats be filled? They've got to be filled by the 2 men. Well, this first seat, we've got 2 choices. We can either put M1 or M2 in here. So there's going to be 2 ways of sitting a man in that one. But for any time that one male goes in here, this seat can only be filled in one other way. So that's going to be 1. Now when it comes to the women, how many ways can they seat themselves in these 3 seats? Well, it's as if, how many different ways can we arrange these letters? 3 factorial. 3 by 2 by 1, because there's going to be 3 ways that you could put someone in this seat, 2 ways for the next, and 1 for the next one. And to get the total of all these, we would times them all together. And if you do that, you'll end up with 12. Now you could use the NPR formula for doing this. There's another way that you could do it. Because the items are different and we're not using replacement, so you could argue that for seating the men, there would be from 2 men. You're working out how many permutations of 2 from 2, 2p2. And then we would need to multiply that by how many ways we can permutate the women. That is, from 3 women, permutate 3. If you do this on your calculator, you'll find you get exactly the same answer here, 12. Okay, what about this second one? You might, as I say, like to pause the video and give this one a go. Okay. Welcome back if you did have a go. What have we got? We've got how many ways can 3 blue books and 4 red books be arranged on a shelf if a red book must be on each of the ends, assuming that each book looks different except for colour. So we can distinguish the books then. So I would call those books, the blue books, B1, B2, B3. And as for the red books, obviously I'm going to call them R1, R2, R3 and R4. So when it comes to looking at the number of arrangements, we'll just put an intro in here, then I'm thinking of filling 7 spaces. 1, 2, 3, 4, 5, 6, 7. 7 spaces with books. So how can I fill the end spaces? They've got to have red books in them. Now there's 4 red books, so I've got 4 choices of filling this first space, so we'll put a 4 there. But anytime I fill this space, a red book's got to go in here at the other end. So that leaves me with 3 red books to choose from, so it's going to be 3 in there. And we're going to need to times all these selections together. So we'll just slip some time signs in there. Now you've got to be careful here because, okay, we've put the red books at the end, we've used up 2 of them, but really we can have red books in here as well as blue books. So we've got now 1, 2, 3, 4, 5 other books to choose from. 3 blue books and 2 other red books, 5 books in all. So therefore, putting books in here is just going to be 5 by 4 by 3 by 2 by 1. 5 books, irrespective if they're blue or a few red, they can be arranged amongst themselves 5 factorial ways. Now if you work that out, you'll find that you get 1440. But again, you could do this one by using the NPR notation. If we were doing it for the red books, how many ways can I fill the 2 n spaces from 4 books? It would be 4p2. And I would need to multiply that by how many ways there were of filling the remaining 5 middle spaces. So that would be from 5 books, permutate 5. Okay, this is essentially 4 times 3, and this is 5 factorial. And so you work that out, you'll get 1440. Okay, well I hope that's given you some idea then of how we cope with questions like this, where there's restrictions and we've got items on the ends of a line of items. Okay, well thanks for listening, and I hope that has been of some use to you.